All right, let's do another example. So now we're going to do definite integrals. So this is, here we go. Again, this is just practice. So we're using everything we've learned. So this is fun. For me, this is fun. It's just trying to figure out a puzzle, right? So here we go. So the easiest thing to do is just do u substitution, right? So let u, in this case, be the exponent, 1 minus x. The du, in this case, is just going to equal negative dx, or negative u equals dx, and now we're ready to do our substitution. Oh, we also have to change the limits of integration, right? So in this case here, if x is 1, then u is 0. If x is 2, what? U is negative 1. Okay? Right? So 1, and if it's 2, it's negative 1. Okay, and then we get what? It's going to be negative e to the u du. Now, it doesn't matter, but we could switch the limits of integration. Because 0 to negative 1, we usually put the smaller number on the bottom. So why don't we switch the limits of integration? What does that do? Remember, if we switch the limits of integration, we switch the sign. So since there's a negative out here, it becomes positive, and we write negative 1 to 0 of e to the u du. Okay? Now, what happens here? This is just going to be e to the u, right? In the general antiderivative is e to the u plus c, but here with the definite integral, we're going to use the fundamental theorem of calculus part 2. So what happens? It's just going to be e to the u evaluated at negative 1 and 0, which is going to equal e to the negative 1 minus e to the 0. Right? No. E to the 0 minus e to the negative 1. And so e to the 0 is just 1, and we get 1 over e, right? And so if we wanted to, we could write this as e minus 1 over e, if we wanted. Okay, but I would just leave it like this. I guess you could leave it like this too. E to the negative e to the 1 plus 1. I mean, we'll drop these. Okay, that's it. Have a great day.